Hello, students. Mr. Sulik here, coming at you with a virtual lesson. For today, this is part two of the mechanical systems presentation that I started off with earlier this week. This presentation is going to be considerably shorter than the one that I posted, whether you're A day or B day, earlier this week, Monday or Tuesday. But we're going to stay within the same theme of mechanical systems. But let's do a real quick review of what we went over on earlier this week. We learned about mechanical advantage and how to figure out, and mathematically, how to figure out mechanical advantage. That was based upon load and effort factors. We also learned about velocity ratio and learn out how that works as well. That's going to be important moving into today's lesson because we're going to need to take that knowledge that we learned earlier this week and apply it to something called efficiency right up here. So, in an ideal world, mechanisms would be 100% efficient. The energy supplied would be the same as the energy produced. So, as much as I would push down on this lever, I would get equal amount of force coming back. But we all know that isn't
For
always
example,
necessarily
if you
the case. For example, if you lift a rock 5 inches by moving the lever through 50 inches, then the effort required should be 1/10 the weight of the rock. So as I push down 50 inches, pulls up 5 inches. In practice, systems are inefficient because of a lot of factors, such as wind, parts twisting and bending, surfaces rubbing, producing friction, energy being lost as waste, heat, and sound. So this rock isn't perfectly round. It's got inefficiencies with the friction that it produces, the wind that might be coming around, depending on maybe even if you're on some sort of incline down below. So we don't live in, a perfect situation for things to be efficient. There is an equation to figure out efficiency. The efficiency of a system is mechanical advantage over velocity ratio. So that's where I alluded to earlier that when we learned about mechanical advantage and velocity ratio, those would be involved in figuring out efficiency. Okay. So don't forget everything we learned about there. All right. Let me erase that and erase this. Okay. So moving into the next slide. The ratio, or I'm sorry, the formula can also be shortened to. This may be written as this symbol is a Greek word called eta, ETA, and that is equal to. It's just another word for efficiency, but in math, it's referred to as eta, ETA, and that is mechanical advantage over velocity ratio times 100%. Okay, so let's do an example here. Got 50 pounds of effort acting upon a 200-pound load. I am pushing it down 30 inches to lift it 6 inches. This mechanism is being used to lift a rock, using the equation to calculate the efficiency. So I need some information, right? We remember that eta, or efficiency, is equal to mechanical advantage over velocity ratio times 100%. I need some information though, right? I need to know my mechanical advantage and I need to know my velocity ratio. Well, we already know that. Going back to earlier presentation, we already know the mechanical advantage of this lever is 4 and that the velocity ratio is 5. Okay, and that's important to remember because that's going to factor into. So I would put 4 up here. All right, 4 up there, and then 5 down below here. Multiply times 100. So I'll get my calculator out. 4 over 5 times 100 equals 80%, and we always are going to round up in these equations. So let's do a problem together. Erase this. All right. So pertinent information that we already know is that mechanical advantage equals 5, velocity ratio equals 6. Okay, so that's our givens. Okay, that's our given. So we have choices of 120, 100, 83, and 66. So let's get our calculator out and try to figure that out. Give you a moment to do so. So we would, eta or efficiency would be 5 divided by 6 times 100 and then round up. Give you a moment to do that. Okay, walk you through the problem here. 5 divided by 6 equals times 100 equals. All right, so I would not need to round that number up. It would just stay at 83. So the closest answer to my question or formula here is, sure enough, 83%. And I'd be right. Efficiency. MA over VR times 100. The efficiency of that equation, or that mechanism right there, is 83%. So let's do just a quick review of everything that we've learned over the last 2 virtual lessons. Okay, number 1, you learn different types of basic mechanisms. Okay, that goes back to simple machines. You've learned about how to calculate the mechanical advantage of a mechanical system. You've learned how to figure out the the velocity ratio of a mechanical system. And then finally, you learned how to use a mechanical advantage and velocity ratio to calculate the efficiency of a system. So I think you just have one question within this Ed puzzle, pretty quick one. 1 or 2 anyway. Make sure that you do get those complete. Continue to work hard on your Rube Goldberg machines. We hope to be next week starting to run those through repeated tests to see how we're doing. If you have any questions, please reach out to me through a message through Google Classroom or an email. Have a great day.